Welcome to Chroma. My name is Kowalski. I'm a sales engineer from Chroma AT Europe in the Netherlands. Today I'm here with Arvind Vijayakumar, who is our application engineer, and also Chris Wedde, who is our design engineer responsible for system build-up. As you could see in our previous video about battery cell safety, we at Chroma developed different solutions to test batteries, starting from battery cells, larger battery modules with BMS on board, and also large battery packs which go in the actual electric vehicle. Today we are standing in front of a battery cell tester. One of our customers who would like to test the quality of their battery cells after they have been manufactured have asked us to come up with a solution for battery cell testing for batteries up to 10 volt, 100 amps per channel, and a device that is able to perform 48 channels testing simultaneously. Therefore, this is the battery test system we have built. Chris, since you built the system, perhaps you can tell us a bit more about it.
Yeah, so this is a 17010 system, as you said, and it's testing for battery cells. And we have, for this customer, they wanted to have 48 channels, so we built it with 4 testers, each tester having 12 channels. And we had to do that in 2 racks, so we had a couple 2 racks together to be able to have this all work together as one single unit. So as you can see at the bottom left and the bottom right here, there's 2 units, and these are the testers. And each one of these testers will be controlled by a converter.
So Chris, it's a very beautiful compact system for 48 channels with such a high current. How can the customer control and run all the tests simultaneously and make sure that all the data is being captured?
So we actually have software to do that, and the software is housed in this IPC, and also the data will be housed in there as well. And it's operated by this KVM at the bottom here. So this is an add-on that you can add for any customer. It's just KVM, which means keyboard, video, mouse.
So Chris, you mentioned about that this device can be controlled using the software. So where is the software, like at the moment in this device?
Yeah, so right now we have the software downloaded that we got from Chroma, and it's LEX, and it's used to create recipes and test programs for each battery cell.
Right.
So that way you can change how you want to test the cell for whatever specifications you need it to be tested for.
Right. And is this device regenerative?
Yes, this device is also regenerative. All 4 of these converters at the top are able to do from AC to DC and then DC to AC.
So which means like the unwanted power can be sent in AC back to the grid, right?
Yes, so if you discharge a battery cell, all that power needs to go somewhere. So these converters are able to either A, send it to another battery cell that's charging, or if your grid allows, send it back to your grid.
Right. And is there any like energy recycling that happens? For example, if I'm charging a device, can I use this channel for like discharging?
Yes. So you can use any channel for whatever you need it for. So if you need it to charge or discharge, or just maintain a cell at a specific voltage.
Okay, got it.
Great. If we look at the system, we have the testers, we have the converters, and very often it's a question from customers: can we control third-party equipment? The answer is yes. The battery LEX software is able to control third-party equipment using the built-in drivers. For this reason, we are able to control environmental chambers, third-party data loggers, but also other safety equipment which is being delivered together with the system to make sure that the people who are testing the batteries are doing it in a safe environment, and that the system will react automatically to avoid potential dangerous situation. Okay, we have seen the front of the device. Perhaps we can now see where the actual magic is happening. We have seen the front of the device and all the devices which are in there, but now we are at the back where the actual magic is happening. On the bottom, we have 4 battery cell testers with 48 channels. The channels can be connected individually to individual battery cells, but in scenarios where you would like to double the testing current or triple it, it is also possible to parallel those channels together to connect to a single battery cell, for example, with a power of 300 amps. On the top, we have the converters, which are responsible for the AC to DC conversion and the regenerative feature of the system. In the middle, the IPC. So Chris, since you built this system, what would be the best procedure to connect the test cables to battery cells?
So Adam, so how we connect the battery cells to the tester is through right here on the back of the testers. So we have 1 through 6, 7, and 12 channels for each tester for the 48, as you said. And we will connect to the top terminal, the positive wire, which will be the red one, and the bottom terminal will be the black wire or the negative on the battery cell. And then we'll also connect the sense cables to the top in this green connector, and that'll go to each terminal on the battery cell, so the system knows that the battery cell is connected to the tester, and that way if it ever gets, and we screw it in so if it doesn't accidentally get disconnected, but it also senses the voltage, and if it did get disconnected or the voltage goes out of spec, it'll shut down the test.
Indeed. And also, worth mentioning, that it will also compensate for the voltage loss. So the tester will be able to give that extra boost to compensate.
Yes.
So Chris, as you mentioned earlier, this device can be customized according to the customer's requirement. So if customer wants any extra safety, can you add it to the device? Do you have any example with this unit at the moment?
Yes, Arvind, we have a relay board in here that can be used for safety reasons, where you can hook up to the facility safety through this relay board if you want to that way, and you can also hook up other pieces of equipment, or you can hook it up externally, so you can control this system from the from an external IPC.
Okay.
We also have at the bottom terminals you can add, and he's already back there.
So Chris, is there any other safety feature that you have added in this unit?
Yes, Arvind, I do. Or we did add a couple of safety features in here. So the first one is these door switches that we put on the back here and here. And that's for when the doors are closed, the system will operate normally. And if anyone opens the door, it will shut down all the system,
Right.
just like the emergency switch on the front would, and which will shut down all the pieces of equipment with the exception of the IPC. We also have a data logger in the front, as we saw earlier, and that's going to measure the temperature of, in this case, this will be a temperature monitoring one, and that will measure the temperature of the battery cell. And if the battery cell goes too high out of specification, it will shut down the test, and the tester making sure that nothing bad happens.
So in that case, we can set some conditions in our software. If it like spec wise for the temperature, and if it goes beyond this, we can shut down the entire system.
Yes. So if in the software you can specify the voltage, the temperature, and a multitude of other things, and if it goes out of those specifications, it will shut down the test to prevent any hazardous situations from occurring.
Let's close the cabinet and go back to the front and to boot up the system.
So now I'll turn on the tester. So yeah, so this is to just turn on the converter. So once it's turned on, We have to wait until this operation glows. So once this is glowing, we can press this on off. And when you press on off, your charger discharger is now connected.
So now that we turned on all the testers, we are going to do a test so that we make sure that everything's communicating. And as soon as these testers spin down a little bit, they will be ready to go. So now that they all did, we are going to hit yes. And they're all communicating properly along with our data box. So let's go ahead and do a test. So we'll go to execution, execution control. It's recovering data from our last test we did. So hang on. Okay. So then we connected to channel 5 on number 1, which we set up as group number 5, which is right here. I have already set this up, but the data box for the temperature is OXT1, and that's already set up. So it's about 21, 22 degrees in here right now. To set up the test, we go to multi-start on the right. Then we are going to choose the test program that I've created, which is TJ1. And that is this test, or this battery cell, Vijayakumar, 3.7 volts. We're going to click drag over to number 5. Click on this folder icon. And put our auto report in the auto report folder we set up. Click this check box in the left of channel or number 5. And if you want, you can call this cell ID whatever you want. So we're going to name it YouTube. I'm going to name it apply. Boom. Channel 5, YouTube is our cell ID. And then we're going to hit start. And then we can see that our channel number 5 is running. And if we start it as a discharge, that way we don't accidentally overcharge the battery. And we can see this is temperature is 22, and if I grab, I don't want to freak you. If I grab this, I'm at about 29.5 degrees Celsius on the exterior of my fingers. Which means I'm pretty cold. And if you want to see all the channels, go to all channels. And then you can see every channel that we have set up. Which is 48. But we also set up the group numbers differently for different tests. As you can see, we grouped up channel group 50 to have 4 cells, and channel 51 or group 51 to have 4 as well. And we also skipped groups since 50 is higher than 48. And this is why the software is not good. So, chamber NA, group 5, channel 5, and we're going to make channel 5, nope, that doesn't work. That's what I want, there we go. Okay. So I'm going to do this. There. So now we have voltage and our temperature. And I don't know. Okay. So if I hit start, now you should be able to see. I have to change this again. So now you can see this is our graph of our battery cell charging right now and our temperature. Our temperature is the blue line and our voltage is the green line. Voltage readings on the right, temperature is on the left, time is on the bottom. And
Thank you for being with us here today. where we had the chance to demonstrate one of our test systems, which is the 17010 battery cell tester. If you have any question about it, you'd like to know more, are you building your own test system, please contact us using the information below, and don't forget to like,
Share.
And subscribe.
see you next time.